Hello, I'm Christina.
Here we are asked to verify the identity. In other words, to prove that the left-hand side of our equation does in fact equal the right-hand side. In general, we want to start with the longer or more complicated side. So I'm going to start by looking at this piece. And I'm looking for ways I can manipulate this half of the equation to make it simpler. I notice here I have a sine squared theta. So I'm going to pop over to my Pythagorean identity, where I see sine squared theta plus cosine squared theta equals 1. I can manipulate that identity to get sine squared theta by itself as such. Once I've done that, I can take this piece and replace my sine squared theta here with instead 1 minus cosine squared theta. Perfect. Now I'm going to distribute this negative throughout what I have just found. So my numerator will be 2 plus 2 cosine theta minus 1 plus cosine squared theta, all over 1 plus cosine theta. Great. Now what I'm going to do is rearrange my numerator, and I want to put it in descending order. What that looks like is rewriting it as cosine squared theta plus 2 cosine theta. And then I can combine my positive 2 and my minus 1 for a total of plus 1 in my numerator. My denominator stays the same. Great. Now I might notice that I can factor this numerator. What that looks like, I break it apart into 2 pieces. And let's go ahead and double check that at this stage. So I'm going to FOIL this and just confirm that I do in fact wind up with what I had originally. Perfect. Great. So now I will notice that my 1 plus cosine theta is on the top and the bottom. These are the same thing, which means I can cross them out. And now my right-hand side of the equation is simply cosine theta plus 1. Perfect. So now I can go ahead and reincorporate my left-hand side of the equation. I'm just going to bring it down from what I had originally, sine squared theta over 1 minus cosine theta. Now at this stage, it'll help me to eliminate the fraction entirely. I can do that if I multiply both sides of the equation by this denominator. So I will continue my work over here, multiplying both sides by that denominator. We'll get rid of the fraction for me. I'm left with sine squared theta equals 1 minus cosine theta, and my original cosine theta plus 1. Great. Now from here, I can again FOIL this. I do first outside, inside, last. Let's see what I get. Perfect. I notice I have a positive cosine theta and a negative cosine theta. Those cancel out. And then I am left with sine squared theta equals 1 minus cosine squared theta. Now I might see that this looks awfully similar to what I have up here. I can then go ahead and sort of reverse what I've done here to get it back to my original Pythagorean identity. All I'm doing is adding the cosine squared theta to both sides. Great. And I know because of my Pythagorean identity that this does indeed equal 1. leaving me with 1 equals 1. I have proven or verified this identity, proving that the left-hand side is equal to the right-hand side. Now we're not done there because they have asked us to just verify that with a graphing utility. So what I'm going to do is input these as 2 separate equations, 2 separate functions into my utility. I click y equals, and I can input sine squared theta divided by 1 minus cosine theta, and then I'll do the same with the second equation, inputting y equals 2 plus 2 cosine theta minus sine squared theta in my numerator and 1 plus cosine theta in my denominator. And once I have done that, I could press graph to verify that they are the same. That way, I can also do this numerically. I want to use my table feature. On my utility, I press second graph, which takes me to the table, and I will see that for every value of x, my y values are identical. That's how I verify it numerically with the graphing utility. And that's it. That's how we complete this problem.